Good morning, children. Okay, now the next topic is how to locate a rational number on number line. We have discussed about the rational numbers, what is the need for those numbers, and in which forms they can be expressed, like that is in the what do you say, fraction form or in decimal form also. We have seen which particular decimals we call as rational numbers, and then we have also seen all the properties which are obeyed and disobeyed by the rational numbers under different operations. Done. Now the point here is that anything on the numbers we use number line, right? Now we started the class also saying that between these integers what do we have? Right? We started with the same question, between the integers what do we have? So that part now we are coming to, right? How to locate a rational number on a number line. Let us categorize that into two kinds. One is less than one category, and if the value is greater than one category. Okay, so that is magnitude values we are taking as. Right, so 1 by 7, here is one example which I am taking as 1 by 7. Denominator is greater than numerator. Absolutely value is less than 1. So it is something like 0.1 and so on. Okay, so this is the condition. Then how to locate this one? Is it necessary for us always to convert this into the decimal equivalent value or not? So sometimes you can convert it into decimal equivalent value and then you can do it. Or the most appropriate one is just keep this as like this and then see the magic in how so many numbers are located between 0 and 1, because it is less than 1. So it lies between 0 and 1. It lies between 0 and 1. So let me take for this the number line like this. Okay, so we have come to a conclusion that the number lies between 0 and 1. Isn't it? That though you are very clear, because you will get, so 7 one time it won't go, so therefore 0 point, you are going to take that one. So now it will be 10 here, it will become 10 here. So what will happen? 7 how many times it will go? One time, right? Then next what will happen? So 3 is the remainder there. So therefore again 30 divided by 7, it is something like that. So 7 4s are 28. Then you are left with 2 as the remainder. So like that you will be going, right? So now it is 0.14 and so on, right? And some other value. So now here that means it lies between 0 and 1, greater than 0 because given is positive. So absolutely it is greater than 0. What the value, whether it is in the fraction form or the decimal form. This is so very clear. So the given value is positive. When it is positive, absolutely value is greater than 0. That is very perfect, right? And now the thing here is that denominator is greater than numerator. Please children keep this in mind. Always check to know whether you are going to get the value to be greater than 1 or less than 1. It depends on denominator and numerator values. If the denominator is greater than numerator, then always the value will be less than 1. Our value will be less than 1. So therefore, here denominator is 7. Numerator is 1. Denominator is greater than 1. So therefore, the result is going to be less than 1. And we said it is positive. That means greater than 0. So now where does the number lie? It is greater than 0 and less than 1. Somewhere in between here. Somewhere in between here the number should lie. Okay. So now very simple. It is very easy if you just pick up the points how to do it. So 1 by 7, it is something like into 7 parts you can divide it or something like that, right? So every value, like I can write it as 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, and this is 7 by 7. What is 7 by 7 is equal to? 7 will get cancelled. This is equal to 1. See, the space between 0 and 1 I have divided into so many parts. How? 1, 2, 3, 4, 5, 6, 7. So I divided that value of like the value which lies between 0 and 1, the whole length, I have divided into 7 equal parts. Okay, so therefore now I have located the numbers. 1 by 7 lies here, 2 by 7 lies here, 3 by 7, 4 by 7, 5 by 7, 6 by 7, 7 by 7 is ultimately 1. Got it? So simple, right? So now where is 1 by 7? 1 by 7 is here. 1 by 7 is there. So you can just extend the number line saying that here lies somewhere like -1, and then the next comes here like 2. So that means between 0 and 1 it lies here. Between 0 and 1 it lies here. So this is how you have to locate a particular rational number on number line. Clear? What are the conditions that you need to check? Whether the given number is first of all positive or negative. Positive means it will go on the positive side of the number line. If it is negative, of course, we will go on to the negative side of the number line. Okay, right. Next, the other thing what you have to check is whether the denominator is greater than numerator or less than numerator. If the denominator is greater than numerator, then obviously your value is less than 1. It is less than 1. So therefore, we can conclude that if it is positive and less than 1, then it lies between 0 and 1. Okay, it lies between 0 and 1. The same one, we shall take it as -1 by 7. What happens? Same. Because you people might be having some kind of confusion. Suppose if I am given a negative number, how to locate it? Nothing to be worried. Same principles. I said like, now you will be moving on to the left hand side of the number line. This is 1. Okay, this is -1. Very good. And therefore it is -1 by 7. -2 by 7, -3 by 7, -4 by 7, -5 by 7, -6 by 7, and this is -7 by 7, which is equal to -1. So now where is -1 by 7 located? Yes, on the left hand side of the 0, between 0 and 1. And where is +1 by 7 lie? Where does it lie? It lies on right hand side of the number line. Right on on the right to the 0 on the number line. So it is of positive value, this is of the negative value. So there is nothing to be confused. If the negative is given, forget about the negative value. And then first check with this whether it lies between 0 and 1. The only thing you have to do is that you draw the negative scale, and division part is the same. Division part is the same. How many numbers you wanted to, means how many parts you wanted to divide that particular unit value. One value only, no? This is from 0 to 1, only one value in form of integers. In that particular integer, into how many parts you can divide. Shall I see one more example? Okay, let me see. Like let us take it as 2 by 3. So I am taking it as 2 by 3. Denominator is greater than this. Denominator is greater than this. So how are you going to look at this? Think for a minute. Like, so 2 by 3, if you just see that, it is 0.36 are 18, and again 6, it is so on. Okay, so this integer we wanted to locate. Where are we going to locate? It lies of course between 0 and 1. Appropriately, it lies between 0 and 1. The number given is positive, so therefore it is what it is going to be. Now the problem is, ma'am, how can we divide right now? So in the previous case, though, in the numerator we have 1. So it is easy to say that 1 by 7, 2 by 7, 3 by 7, 4 by 7, and 7 by 7 is finally 1. So ma'am, how are we going to divide this one now then? So which value have to make this one represent like this, like between 0 and 1? So we have to get something like 1 only here. Okay, we have to get something like 1 only here. And when we take the decimal values here, decimal value is 0.666. That means absolutely it lies after 0.5. Very pretty well known, right? It lies after 0.5. What is the 0.5 value? 1 by 2. Is it not? It is 1 by 2. Now if I multiply it with 2, like in the denominator and numerator, it will come out to be 2 by 4. It will come out to be 2 by 4. Okay, so now I have to locate 2 by 3. I have to locate it as 2 by 3. So now you may say 2 by 2 is equal to 1. Okay. Think how you have to think when you get something which you think that it is something like a little bit different. How you have to think, not just depending on the teacher always or on the book always, with the knowledge what you have, how to think about it. So my one value is 2 by 2. So half value is 2 by 4. Is it not? It is 2 by 2, 2 by 4. So somewhere here it lies. 2 by 3 lies somewhere here. Is it not? So 2 by 4, 2 by 3, 2 by 2. This is how it is. Then how uniformly can I divide it? How uniformly can I divide this particular line? So this is 2 by 4 is 1 by 2. So now where does 2 by 5 lie? Somewhere here. 2 by 5 lies somewhere here. Okay, so now 2 by 5, 2 by 4, 2 by 3, 2 by 2. Clear? So now I can divide this one like between like 0 and 1. This is half 2 by 3 lies. This is where 2 by 3 lies. This is when we are changing the denominator. This is when we are changing the denominator. Right? So, but is it uniform division? Is it of uniform division? See, 2 by 2 is 1, 2 by 4 is 1 by 2. But 2 by 3 is not that which lies exactly between 2 by 4 and 2 by 2. It's not. It does not lie exactly between 2 by 4 and 2 by 2. Then what to do? Then how are we going to solve this problem? Okay, so how to solve these things? And let us suppose that we can make it as 1 in the sense I can divide it into what do we say, let us multiply this with 3 times 3 2s are 6, 3 3s are 9, or rather I wanted to get it as 1, is it not? So I can only conclude like, suppose if I am going to come till 6 by 6, till 6 by 6, suppose if I say I have to come till 6 by 6. So whatever I have, I can divide it in terms of like this, is it not? 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6 and so on. Okay, right. If that is the case, how it is going to be? See, I did not directly say you that this is how you have to do. I made you people to think how to do it. So the easiest way is, now let us multiply. Like this one with 2 and this one with 2. What are we getting? We are going to get it as 4 by 6. So 2 by 3 is equal to 4 by 6. We all know this pretty well. We all know this pretty well. So therefore, if you people cannot like do this one directly, why? Because in the numerator there is a value which is greater than 1. Which is greater than 1. So you can't just simply say 1 by 7, 2 by 7. It is easy here to say. So therefore, you do one thing. You multiply with the second digit. So that is the 2. 2 by 3. Multiply and divide the denominator and numerator, the thing, fraction with 2. So that means multiply the numerator with 2 as well as multiply the denominator with 2. So 2 by 3 will be equal to 4 by 6, that we know. And now to get 6 here, get 1 here, what should be the value? 6 by 6. Is it not? To get value 1 here, it is 6 by 6. Now this is to get 0, it is 0 by 6. Yes, now see, again the numerator has become something like that where I can just keep on increasing the numerator, keeping the denominator constant. The job is very easy now. So I divide it into 6 parts now. 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6 and 6 by 6. What is 6 by 6? It is equal to 1. 0 by 6 is equal to 0. See, the job has become so easy. Now 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6. Now you may say, ma'am, but we don't have 2 by 3. What is that? 2 by 3 is equal to 4 by 6. So therefore, wherever 4 by 6 is there 2 by 3 is. 4 by 6, this is equal to 2 by 3. This is equal to 2 by 3. Very interesting, na? See, if it is given in this form, it will be very easy for anyone to do it. Okay, and but if it is given like 2 by 3, 4 by 5, 6 by 7 or 6 by 8, something like that. So then how to do it? So first you try to make this one to the simplest form. Okay, 2 by 3 is simplest form. Suppose if 4 by 6 was only given to you. Okay, then 6 by 6 is 1. Directly you can easily say that, is it not? 6 by 6 is 1. So you can start with 0 by 6 and go on. But here 2 by 3 is given to us. So you have to bring it in such a manner that your final one, this 1, should come up with the value 6 by 6 is equal to 1 or 7 by 7 is equal to 1. And this value should be something that where you can easily go ahead with a stepwise increment in numerator. See, stepwise increment in numerator. So 0 to 1 it has increased, 1 to 2 it increased, 2 to 3 it increased, 3 to 4, 4 to 5, 5 to 6. Is that clear? So therefore what you are doing, you are taking the equal fraction, means another fraction which is absolutely equal to this, and then you can convert it into the number line, right? And then thus you can locate a number on the number line like this, right? So this is the case where you are going with if the value is less than 1. If the value is less than 1, here you got 0.14 something and here you got 0.666 something, and on the positive line how to take and on the negative line how to take. You are done with that, right? Now the second one is when the value is greater than 1. When the value is greater than 1, how to do it? Now see this one, 13 by 2, definitely because denominator is less than numerator, it is something like 2 6 are 12. Okay, and you are left with 1 by 2. So that means what am I doing? I am converting this into mixed fraction. I am converting into mixed fraction. 2 6 are 12. 13 minus 12, 1, 1 by 2, 6, 1 by 2. What is the meaning of 6, 1 by 2? It is 6 and a half. 6 and a half means 6 plus half. It means 6 plus half. Where does it lie? It lies on the number line between 6 and 7. Where does it lie? It lies exactly, it is greater than 6. But of course not 7. So 6 and 7. So just I have divided into 2 units, that's all. This is 1 by 2 half. Very easy. So 6 plus half. Suppose you are getting 6 plus 1 by 3, something like that. You do similarly as how you have done. Divide it into 3 parts. 0 by 3, 1 by 3, 2 by 3 and 3 by 3 multiplied with 7. Yes or not? So therefore where is it located? It is between 6 and 7. So this is the line. By mistake also don't keep it as 0 and 1 please. We are locating it in number line. Already 6 is counted. After 6 it is half. That means here 6 and half. This is half. It is located in the number line. Of course all the numbers fall here. 0, 1, 2, 3, 4, 5. Then comes 6. Between 6 and 7 exactly at the midpoint you will get this one. So whenever the value is greater than 1, that means whenever the denominator is less than numerator, then you have to convert that into mixed fraction and then convert it into addition form and then see where it lies. Here though it is greater than 6 and less than 7, therefore it lies between 6 and 7. What is the value given? 1 by 2. That means you can only make 2 divisions. This is 1 division and this is 1 division, absolutely at the midpoint it is. It is absolutely at the midpoint. This is how you have to locate the rational number on a number line. Locate the rational number on a number line. Okay? Pause the video for a moment, children, and copy it down and take as many examples as possible, your own examples, and try to solve them. Right? If you are unable to solve any of the example what you have picked up, just post me so that in the next video I can cover that one. Okay? Pause the video for a moment before we go to the next part. So copy this down. So now done. Next part. Finding n number of rational numbers between any two numbers. N number I said. It could be anything. 2 rational numbers, 3 rational numbers, 5 rational numbers, 10 rational numbers between any two given numbers. Between any two given numbers. Right? So now this n can be anything. Now let us take one particular example. Example 1. Between 2 and 3. And I just wanted to find out number of rational numbers. 2 is an integer, 3 is an integer. Before though we had only 2 as a number, 3 as a number. But we now after entering into rational numbers, we discussed no, between 2 and 3 there will be so many numbers. So now out of so many, he is asking just to locate 5. It is very easy. So now let us see how to locate. I will give you 2 methods here. So, he is asking us to locate first between 2 and 3. Okay? Between 2 and 3. Already we have learnt in the previous, just now, that better we divide into number of parts. Okay? So, now when I say it is between 2 and 3, let me, 5 rational numbers, so I want to equally divide 5 parts. Then only I can easily say equal division, right? Because in the previous case we have seen 2 by 3. You can't keep changing like denominator and say that this is how it lies, because exact location we can't find out like by changing the denominator. You have to fix the denominator. Okay, you have to fix the denominator. So let me fix my denominator with 5, so that I can divide it into 5 values, right? So therefore between these two, this is of 1 unit, is it not? This is of unit value or not? This is of 1 unit value or not? Unit means 1, is it not? Between 2 and 3, what is the difference between 3 minus 2? It is 1. So it should start from 0 to 1. That is how I have to divide. So let me write, right after 2, I wanted to take 2 1 by 5, 2 2 by 5, 2 3 by 5, 2 4 by 5, okay, and then 2 5 by 5. Okay, so like that. So therefore 1 2 3 4 5. I have split it into 5 divisions. Is it not? 5 divisions right now. And now here, so what is this? After 2, it is 2 1 by 5. That means 2 and 1 by 5, which is equal to 2 1 by 5. Mixed fraction. Just the previous example we have seen how to convert an improper fraction to mixed fraction and then do it. This is other way around, that's all. So 2 and 3, between 2 and 3. Just simply close your eyes and whatever you wanted, how many rational numbers you want, 10 rational numbers you want. So you start with 1 by 10, 2 by 10, 3 by 10, 4 by 10, 5 by 10, 6 by 10, like that. Okay, so now I have 1 by 5, 2 by 5, 3 by 5, 4 by 5, but you can't take just 1 by 5 as your location. You have to take 2 1 by 5, 2 2 by 5, 2 3 by 5, 2 4 by 5. These are the rational numbers, okay? So, 2 1 by 5, let us convert it as 5 2s are 10, 10 plus 1, 11 by 5. So, one number is 11 by 5. Okay, and now next one is 2 by 5. It is 2 by 5. That means 2 5s are 10, 10 plus 2, 12 by 5. And 2 3 by 5. So it is 2 5s are 10, 10 plus 3, 13 by 5. Then 2 4 by 5. So that is 2 5s are 10, 10 plus 4, 14 by 5. Okay, right, now the last one. So whichever it is, into 5 divisions, right? 1 by 5. So we have 1, 2, 3, 4. And what is the last one? It is going to be 5 by 5. Right? 5 by 5. It is like almost equal to 3. So let us see here. 2, 5 by 5. So that is 2 5s are 10. 10 plus 5, 15 by 5. What is that equal to? 3. Okay, so now we are getting only with 4 rational numbers between 2 and 3. It means excluding 2 and 3 we are finding now. Excluding 2 and 3 we are finding. Just I wanted to make you people understand how come this 5 by 5, 2 5 by 5 can be 3. Okay, so if we take 4 rational numbers here, I am dividing it into 1 by 5, 2 by 5, 3 by 5, 4 by 5. And like what did I do? But when I am taking 4 rational numbers, I have increased the denominator value by 1. By 1. Okay, suppose if I wanted to have 3 rational numbers between 2 and 3. Okay, suppose I wanted to have 3 rational numbers between 2 and 3. So I have to take the denominator value to be 1. Okay, let us see. 2 and this is 3. So I'll take it as 1 by 4, 2 by 4, 3 by 4 and then comes 4 by 4 here. So equal divisions comes here 4 by 4. Now let us check. So what is this value? This number is 2 1 by 4. You can't write it as 1 by 4 because it is after 2. It is not after 0 to write directly 1 by 4. 2 1 by 4 means 2 and 1 by 4. That is 2 plus 1 by 4. How much is added? 1 by 4 is added to 2. Right. So therefore 4 2s are 8. 8 plus 1 9 by 4. The other one 2 2 by 4. So 4 2s are 8. 8 plus 2 10 by 4. Okay. Next 2 3 by 4. That is 4 2s are 8. 8 plus 3 11 by 4. So 2 4 by 4. It is obviously 12 by 4 because you can see that the numerator is increasing 1 by 1 step. See, absolutely uniform change. Okay, now 12 by 4. 3. Of course, this is the 3. So, 3 numbers. We want 3 numbers between 2 and 3. That means we are excluding 2 and 3. If we are including 2 and 3, not an issue. We can easily do it. Right? 2 and 3 are excluded. So, what are the things? 1 by 4, 2 by 4, 3 by 4. So, what is the general rule that you have to remember here is that whenever you are asked to find number of rational numbers between two numbers, excluding them, so how many rational numbers are asked? You add to that number. That means if n rational numbers are asked, your denominator should be n plus 1. While you are, that means you have to make n plus 1 divisions. Okay, right? That by 1 by 5, 2 by 5, 3 by 5, 4 by 5, it is 4. Now if it is like 3, so we are asking like between 2 and 3. 3 rational numbers. 3 rational numbers between 2 and 3. If we are taking between 2 and 3 with 3 rational numbers, what are we doing? We are taking 1 by n plus 1. 1 by n plus 1, 2 by n plus 1, 3 by n plus 1, 4 by n plus 1. Did you get? So this, when you do it like that, it is easy for you to locate how many are asked. If 100 are asked, okay, 100 rational numbers, what your denominator value should be? 101. And you have to start with 1 by 101, 2 by 101, 3 by 101, 4 by 101, 5 by 101. Right? So this is how you have to locate the, like find number of rational numbers between the two given numbers. Right? It is very easy, uniform and easy to do it. So the only thing you have to remember is if n rational numbers are asked, so your denominator value should be n plus 1 while you are dividing it into equal divisions. Okay, so 1 by n plus 1, 2 by n plus 1, 3 by n plus 1, 4 by n plus 1 and so on. So I'll write it here. If you want n rational numbers, I'm writing it as q numbers, q in the sense rational numbers, then you must start with 1 by n plus 1, 2 by n plus 1, 3 by n plus 1, etc. lies between the given numbers. Right? So these many numbers will lie. So whatever you want, right? Okay. So what the thing you have to take is, you should not write 1 by 5 as a rational number which is between 2 and 3. No, it is 2 plus 1 by 5, that is 2 1 by 5. You can't write 4 by 5 as a rational number between 2 and 3. Please remember this. It is 2 plus 4 by 5. So 2 4 by 5. Clear, children? So go through the whole thing again and watch the video twice, so that you will be able to understand the logic behind it. How we have to take, why we are taking it like this. Clear? So I will stop this here, and next class we will learn another method, that is a mean method, finding the average. That means by finding the average between two numbers, you can find out a number which is exactly between those two numbers. Likewise you can find number of rational numbers which are between the two given numbers. But this is the one which one, if you can take this logic into your mind, it's the easiest way to do it. Okay, but in the examination they will specify it, like by using mean method or average method. So therefore that method is also important for us to learn, right? So pause the video for a second and then please copy it, and if you have any doubt, please rewind the video and again just see what explanation I have given, why we are taking it like 5 here when 4 rational numbers are asked, because this is not included here. If you go for 5, that is also included. Okay, so if that is included, then no harm, you can take it to 5 like that. Okay, right. So carry on with this work and try to take as many examples as possible, and also take whatever gets into your mind of unit value, and between that see how many rational numbers can lie. Okay.